And welcome back to my channel. This is another example on MSTs. If you like the contents being shared here on this playlist, please remember to subscribe to my video, like and share. It's totally free to subscribe actually. So let's look at this example. We have this graph and I'll be solving the A question, and I would like for you to solve the B question using the idea we shared and the question before this video, in the video before this one. So we want to run a Prim's algorithm, and whenever there is a choice of nodes, we use alphabetic ordering starting from node A. So we want to draw a table showing the intermediate cost of array. So let's put down that table first. We have, let's call this the node, and let's call this the cost. So we want to start from node A. At node A, you remember for the Prim's algorithm, we start with the vertex, right? We start with one vertex. So let's call that, since we are going in alphabetical order, let's call that first vertex A. We're going to start from A. And then what Prim's algorithm says is you start from one vertex, you attach the cheapest edge that does not form a cycle. So we have A from this graph. What's the cheapest edge from A? From edge you have 4, you have 8, you have 1. So 1 is the cheapest. So you go from A, this is 1, to B. So in our table we want to update from A to B. We have cost 1. And from B, what happens? From B, you have 6, you have another 6, and you have 2. So from B to C, that's 2. This is actually how the Prim's algorithm works. So from C, you have 2, you have 3. So we are going to go with what's cheaper. G is cheaper. Let's see. From C, you have C to D, that's 3. You have C to let's move. You have C to G, that's 2. So which one do we select? That's a question. The question says whenever there is a choice of nodes, always use alphabetical ordering. Because of this instruction, we are going to go with D. But usually, if you were not asked to use an alphabetical ordering, it's cheaper right now at this point to go with G, right? G, this guy. But because the question says go in alphabetical order, whenever you have something to choose in alphabetical order. So we are going to go with D. I hope that reasoning makes sense. So we have 3, D, 3. So what happens? We have from D to H 4, D to G 1, and yeah. So what do we choose? We're going to, D to H is 4. We also have D to G, sorry about that, D to G. Let's just put down the whole thing at once. So let's move from D to H, that won't work. We have from D to, let's start from this point again, since we are going in alphabetical order. We have from A to E, that's the cheapest. You have 4, since we are moving in alphabetical order. So we have from E, what happens? You have E to F, that goes, that's 5. So you have E to, oh my pen is just messing up, sorry about this. So because we are moving in alphabetical order, after D, let's go to E. So you have E. So what happens at E? From E, you have edges that cost 4 and the other one that cost 5. So we go with the one that cost 4. So we have E here, 4. We move on to F. Since we are going in alphabetical order, what happens? We have 5, 8, 6. So we go with 5. This is 5, F5. Then we move on to edge. We move on to vertex G. G goes 1, 6, 2. So we choose 1, 1, G, 1. And now we have H. H goes 1, 1, 4, 1, 4. And from G we have 1 to D, 1 to H. And so the thing is, if we choose this one, it forms, we have a cycle. This choosing the edge G to D, even though it's cheap, 1 forms a cycle with the whole graph. So we don't want that to happen. So we choose G to H, which cost 1. So you have here 1. And the cost of this MST is 18. I'll leave the second question for you to try. That's running the Kruskals algorithm on the same graph. If you have any confusion, refer to the last video before this one. It also asks that you show the disjoint set data structure. So that means that for every step in your Kruskals algorithm, you draw a new graph. That's what it means. So you want to draw the graph step by step, step by step. We'll end this video here and I'll see you on the next one. If you haven't subscribed, please do subscribe and I'll see you on the next one.